Hi, so in this video I want to show you how to use SpacePixels, a very quick tutorial in a way. Uh, First I want to show you how to prepare the input for SpacePixels. So this is Deep Sky Stacker. Like the input to SpacePixels is basically the output of Deep Sky Stacker. In what sense? That okay, normally you select the pictures you have selected, and then when it comes to stacking, this is the important setting here, stacking parameters. Okay, intersection mode definitely, so that all pixels have the same size. So this is an important parameter. Then here, intermediate files, create a registered calibrated file for each light frame, fits format. So this is enough. You have all the other parameters in the end are not so relevant for now, for the tutorial. So okay, we leave it working. So Deep Sky Stacker finished. It created our input for SpacePixels, which is this set of registered aligned pictures. So let's go. This is SpacePixels. Okay, I'm gonna do that again. So I'm gonna say import aligned fits files, and I'm gonna go like choose a folder. I'm gonna go to M81 red. So I just moved all the pictures. Now this is not this is from a previous run, so I'm just gonna go use those register files, which are actually those here, and you see we get some information about those files initially. Now these are from a Canon, I think, so in the end they're quite noisy, but let's see. Yeah, this is from a Canon. So let's see if I go now. First of all, we get this list which has some information about each file. So each line is one file. Here are all the files, and you see the file name, if it's a mono or a color image, the width, length, some elements on the feeds header. Typical for Canon, you get a few elements on the feeds header, and then if it's plate solved or not. And let me first show you how we can plate solve a picture. Now automatically this kicks in the stretching. I'm gonna take it off. So I select one of those pictures and I say I want to plate solve it either with, I can do it either with ASTAP or astrometry.net. This is the online version, and for ASTAP I have a local installation here. So basically from here, if you have ASTAP installed, you select the path, which I fully recommend. See program files, ASTAP, and then you say this is the executable, and you get also this so that you're sure, like it's just an indication that yes, it's working. And now let's say I want to solve this picture with ASTAP, so I just click. ASTAP is working in the background. Here you can see already it started, it's looking. Here you can see the field of view. It's trying to now this is a wide picture, so it's going to be solved quickly. Now the narrower the field of view, yeah, image was successfully plate solved, because I'm doing a blind solve, and at this version SpacePixels always does a blind solve, even though here it says you can put some parameters, deduce it from the feeds header if it's there, but it actually does blind solve. For the next version I'm gonna use these parameters to do near solve, both ASTAP and astrometry.net. Okay, so now I can also see the annotated image from ASTAP, M81, M82, cool. This is generated from ASTAP. And now one fun thing that I really do is, so okay, these are all the pictures, and then I say stretch. Now these are very noisy, so I'm gonna use another example later to show you. These are DSLR, very noisy pictures, but still, I guess it's fun to look at the data this way. So let's see, I don't know, too bright maybe. Okay, let's say we want to look at that. So that's the amount of stretching I want to do. And then now if I go here and I select a few and I say like, okay, oh, control some more, so just select 3 or 4 just to demonstrate, and I'm gonna say now blink. And what it's gonna do, it's gonna load those images and kind of animate. Yeah, you can see here it's already animating. And this for me is really fun. I mean, this is what I this is what I mean, to have a bit of fun with the data, see what was going on in the dimension of time. So because usually all this is lost, and now I can just quickly have a look, see if something is, see basically what was happening while I was taking all those images of M81. Hmm. It's a really fun way to inspect the data. Oh, here you can see some noise moving, probably. Yeah, this is probably noise. Maybe. No, but because it's green, it's noise, and all noise moves that way. You can see some. With DSLR pictures, they're quite noisy. Yeah, so this is blinking, stop blinking, and basically now I can either batch. So one other function of SpacePixels is, besides solving and apply the solution. So if I select now this picture, I can apply the solution to all images. So it will update the fits header on all images, and at the same time it will batch stretch using these parameters from the algorithm here. So if I say now apply solution, it will just go and recreate all those. It will create new folders, one folder for each. I'm gonna explain to you what it's creating. So let's just say apply solution. So there are a lot of files, so it's probably gonna take some time. But in the meanwhile, let me go there and I'm gonna explain to you what's going on. So this is my Aston. Now we are at M81, light M81. Yeah, we're in here. Okay, it's already working. It's already creating those directories with the updated fits files. So it creates usually 4 directories if it's a color picture. And what it does is, first it finished. Okay, so in the solve folder it has updated, it has recreated those fits files with the information about for the plate solution. Then it has converted them to mono version, to the monochrome version, and then again the same thing, mono and with the information on the from the plate solution, both stretched. So let me just to show you like what. No, I mean we can also open a file like, let's see, solved mono. Let's just open that. Cool. And it has the nice thing is it has the additional information in the fits header, and this is useful in case you want to use now those files with another tool for whatever reason. And yeah, so you have a set of kind of stretched. Let's open the stretched now. Boom. Yes, nice. So you have a set of stretched, but you have a tool for batch stretching fits files, and at the same time, if needed, because you can only do batch stretch if you want, at the same time you can also update the fits header. So let me do another kind of, to show you another way of using the tool. So I'm gonna open, now it has to do with blinking. So at some point, some years ago, I wanted to take a picture of the Integral spacecraft, and for some time I wasn't really sure I even managed. So let's go, let me show you. So now it opened those. So it was with a very small CCD camera. And here, let me open one. So this is already a monochrome, we can see here. So it's already a monochrome short. And let me see. So here on the algorithm, yeah, let's see, iterations. Show full size. Ooh, very bright. Ah, no, we're actually outside of the. Okay, this is a bug I need to fix. Let's see. Enhance low, maybe it's no, enhance high. And so the reason is I want to show you this extreme, and so enhance high. So even stretch, I had really trouble locating if I had taken a picture of integral or not. So now if I say blink, blinks those images. Yes, you can just see it. It's because I know I've seen it. You can just see it passing by here. It's very close to the noise level. So now, what's the cool thing with this extreme? So if I go here, basically this is how bright. So this extreme stretching algorithm, what it does is basically above some threshold, and you can choose. It already is near the noise level. You can choose. Let me show you full size. So above a threshold, it just above a threshold, it just completely brightens the pixels. So and here it's already set to be close to the noise level. So let's blink again those files, and you can now very clearly see it. So here it is. So this is a very cool thing. If you have to see something moving very close to the noise level, you can use this extreme kind of stretching function. So in a nutshell, this is SpacePixels. It's a fun tool I created to have an extra look at the data in the dimension of time. Ideally, in the next version, I wanna detect moving objects directly here, and this is gonna be real fun. But for now, you can do blinking with various algorithms, batch stretching of fits files, plate solution, and also to apply the plate solution, because now we have a really nice set of fits files, and if you all aligned, all looking at the same part of the sky, and if you apply the plate solution to all of them, I mean, you just increase the quality of the data you have captured, and this is also quite nice. Thanks for watching.